Hey guys, so today we're going to be doing a question involving a current amplifier. So they tell you that you have a current amplifier with an input resistance of 1 kilo ohm, an output resistance of 10 kilo ohms, and it tells you AIS equals 100 amps per amp. It's the current gain, and we'll come back to what that AIS actually means later. They tell you that it's connected to a 100 millivolt source with that signal resistance and that load value, and they want you to find the value of the current gain, and they tell you how it's defined, the value of the voltage gain, and they tell you how that's defined, and then the value of the power gain, and they want all of those both expressed directly in this format and expressed in the decibel format. So we'll show you how to do that. So first of all, the current amplifier, you need to know what the circuit diagram looks like for that. If you don't know what it looks like, it's just you got your two input terminals, between which there is an input resistance, and then typically this bottom terminal is ground, and then you got a dependent current source and an output resistance in parallel with it, and then you got the output terminals. And so this one is R in, this one is R out, and this dependent current source puts out a current that has a value of AIS times II. You can't really see that. Times I sub I. And that I sub I is the current entering right here. And so this AIS is what's called the open loop gain. So it's the current gain that you experience when there's no load hooked up. Right now, we don't have a load connected between those two terminals. And so AIS would be the gain if we were to connect some sort of current source over here. We multiply the current that's coming in from that current source by AIS, and that'll give us the current that's basically going through RO, because there's no, like I said, there's no load resistor right here. So that's the current amplifier itself. So we'll just draw it inside a little green box so you know that that's what that is. And then everything outside the green box is going to be the rest of the circuit. So you got, it's hooked up to a a voltage source with a resistance R sig, and you got V sig here. That's just some standard notation. And this is 100K, and we can go back and put these other values in. You got 1K here. RO is 10K. I'm not going to use the ohm symbol every time, it's just irritating. And then on the output end, you have you just have a single load resistor, RL, and the value of that is, where is that? Load of 1K. Okay, so now we have the circuit drawn, and we can start finding the values. So first we want to find the current gain. So the current gain is defined as IO over I sig in this case, or II. So I sig would be the signal generator's current if this was a current source. So this stuff over on this side isn't actually a current source, it's a voltage source with a resistor in series with it. So you can do a Thevenin equivalent and turn that into a Norton equivalent and turn that into a current source, but it doesn't really matter. All you really want to do is just find this current II that's coming through. So this 100 millivolt source through that 100 kilo ohm R sig is going to put through an II of whatever. You can find that with Ohm's law. So really the way we're going to do this is the output current over the signal or input current is this symbol here, A sub big I, and it's going to be somehow related to I sub or A sub IS, the open loop gain. So we're going to take this open loop gain and we're going to try to multiply it by something that will adjust this open loop gain based on the fact that we have this RL hooked up here. So the output current here, remember everything in the green box is internal to the amplifier. So the only current that's going through the load, the current that's going through the load is the only current that we can measure from outside the amplifier. So the current going through the load is what really matters. So that's going to be this current here that we're going to determine with a current divider equation. So we want to find the RL current. So that's going to be, you know, the current divider equation. It's going to be the branch you don't care about over all of the branches. And then you can multiply that by A sub IS, and that'll give you AI. And so then you just plug in the numbers, and you get 100 amps per amp times 10K over 11K, because 10K plus 1K. And so if you crunch the numbers, that'll give you 90.91 amps per amp. And that is the current gain expressed directly. And so if we want to express it in decibels, let me just scroll down here. What we're going to do is take 20 log base 10 of the current gain. And that gives us the magnitude of the current gain expressed in dB. Oh my god. Expressed in dB. So that's going to be 39.17 dB when you plug the numbers in. And so that's the value of the current gain expressed in decibels. And so you can write all this down, and then we'll go ahead and find the voltage gain. And so the voltage gain, defined as VO over Vin, is going to be similar. It's, well, first of all, we can rewrite VO as IO times RL, because it's this voltage here. This is VO. It's the voltage we measure at the output. So it's only going to be across this RL resistor. So that's just Ohm's law, replacing VO with IO-RL. And that's still over VI. And we can rewrite that as IO-RL over, and now we're going to replace VS with another expression, so it's going to be II-RS plus RI. So where did that come from? So you got your input current times the sum of two resistances, which is R sig plus Rin. So that is Ohm's law again. It's the voltage at the input expressed in terms of the current through the input resistances. And so now what we have is something that looks similar to what we had before. We have this IO over II, which, if you remember from before, is the definition of A sub I, A sub IS. And you're going to have all that times RL over RS plus RI. And so now we've just put everything in terms of stuff that we know. The I over II becomes the A sub IS, and then all this stuff is resistances that we know. So that's going to give us 100 amps per amp times the 1K load over the 101K sum of the input resistances there. And so that's going to give us 0.99 volts per volt. So the voltage gain is just slightly less than 1. And that kind of makes sense because this is a current amplifier, right? So you're not expecting that the voltage that you get at the output is going to be significantly different from the voltage at the input. because what you're amplifying is current, and what happens in the voltage domain isn't so critical. And so now you want to find it in decibels, so you're just going to do the same thing as before. You take 20 log base 10 of the voltage gain, VO over VI. And when you work that all out, you get negative 0.027 dB, because remember, if you have a gain of less than 1, that corresponds to a negative decibel gain. And so that's your decibel gain for voltage. And now what we want to do is find the power gain. So let's just erase this again. You can write all this down, and then we'll go ahead and find the power gain. Oops. Didn't mean to erase the circuit. Okay, so now the power gain is defined as the voltage gain times the current gain. That's similar to the expression that you know from first year circuits where P equals VI. So that's where this came from. So if you plug in the numbers that we got from before, you're just going to have the 90.91 amps per amp, and you're going to have the 0.99 volts per volt. And if you crunch those numbers, you're going to get 90 watts per watt approximately. And if you want to find that in decibels, you can do the same thing again. You just take 20 log base 10 of 90 watts per watt, and that's going to give you 19.54 decibels. And so that's the power gain expressed directly and in decibel form. So yeah, that's the whole problem. If you have any questions, feel free to email me. This might not have been the clearest video, especially that step where you're turning A sub IS into AI. That can get kind of confusing. So if after you've sat and thought about it for a while you still don't get it, feel free to contact me. The info is in the link below, or the link to my email is in the box below. So yeah, good luck with this.